So in section 10.4, we're going to talk about compound events. What happens when more than one thing happens at one time? For example, what is the probability of flipping tails 4 times in a row? That's what we're going to talk about now. So right here, we have a definition. It says that the set of all possible outcomes of one or more events is called the sample space. So all the total possible outcomes that you could get for one event or more than one is called the sample space. You can use tables and tree diagrams to find the sample space of 2 or more events. Now, while I'm going to show you some of the ways the book tells you how to get sample space, I'm going to show you a much easier way, and I'm hoping you can use that, or if you want to use what the book says as well, that's fine. But I want to show you all the possible ways to get that answer. Now, in the first example, all I want you to do is I want you to find the sample space when you randomly choose a crust and style of pizza. How many different pizzas are possible? So the sample space is how many total pizzas can I make with 2 kinds of crust and 4 kinds of pizza. Now, if you really wanted to, you could take your kinds of crust and you could take the style that goes along with it and you could make some type of diagram. Now, personally, that's a lot of work, so you wouldn't have to do something like that. And here it is. I have it written right here. But you could have, your thin crust goes to these 4 kinds and this stuffed crust goes to these 4 kinds. That gives you a total of 8 different pizzas. So there's your answer. 8 different outcomes or 8 different pizzas. But the easiest way is this. There are 2 kinds of crust. There are 4 kinds of pizza. All you have to do is take 4 multiplied by 2. 4 multiplied by 2 is 8. That's it. Which leads us into exactly what we did. Another way to find the total number of possible outcomes is use the fundamental counting principle. The fundamental counting principle. Now, this can be extended to more than 2 events, but an event M has M possible outcomes. An event N has N possible outcomes. The total number of outcomes of an event M followed by event N is just M times N. So in the last problem, we had 2 kinds of crust. We had 4 kinds of pizza. That would be 2 times 4, which is 8 total possible outcomes. So example number 2, really easy. Find the total number of possible outcomes of rolling a number cube and flipping a coin. We have 2 events here. How many different possible outcomes are there from rolling a number cube? There are 6. How many sides are there to get for flipping a coin? There are 2. 6 times 2 is 12 possible outcomes. Super easy. So here's our next example. Find the different outfits that you can make from t-shirts, jeans, and shoes in the closet. So if we're looking at this, we have 3 events. T-shirts, jeans, and shoes. So if we look at the top, choosing, it looks like these are jeans right here. It looks like there are 4 pairs of jeans. And then we're picking shirts. There are 1, 2, 3, 4, 5, 6, 7 shirts. And there are 3 pairs of shoes. So 4 multiplied by 7 multiplied by 3 gives us a total of 84 different outcomes. Or in this case, we're talking about outfits. So the next thing is talking about a compound event. A compound event consists of 2 or more events. As with a single event, the probability of a compound event is the ratio of the number of favorable outcomes to the number of possible outcomes. Now the book only shows you one way, I'm going to show you 2. Here's example 4. It says in example 2, what is the probability of rolling a number greater than 4 and flipping tails? So here is what the book says to do. This is completely up to you what you want to get, or what you want to do. So if you want to do the probability of greater than 4 and flipping tails, you could find the total favorable outcomes. Well, we could have, for example, greater than 4. That means we could get a 5 and a 6. Well, tails, that means I could either get a 5 and a tails or 6 and a tails. That means I only have 2 favorable outcomes of rolling something bigger than 4 and flipping a tails. Well, the total number of outcomes would be, well, there's 6 times 2, because there are 6 sides on a number cube and 2 sides on a coin. That gives me 2 twelfths, which simplifies into a probability of 1/6. Here's how I do it. It's completely up to you what you want to do. I do each event as a separate number. So the probability, for example, of a number greater than 4. I would just do that as how many numbers are greater than 4 on a number cube? There are 2. So it would be 2/6, which is 1/3. The probability of doing tails, that would be 1/2, because there's only one tail out of 2 sides. So I take my 2 fractions and I multiply them together. And 1/3 multiplied by 1/2 gives me the fraction 1/6. So the probability is 1/6, or as a percent, 16 2/3%. In example number 5, we want to find the probability of flipping 3 nickels. What is the probability that we're going to get 2 heads and 1 tails? So we want to flip 3 nickels. So in this problem, once again, the probability of we want 2 heads and 1 tails. The first thing we have to do is the number of favorable outcomes. So if you flipped 3 nickels, I could have a heads, and a tails. I could also have a heads, a tails, and a heads. And I could also have a tail, and a heads, in that order. So what is the probability that I'm going to do that? Well, how many outcomes are favorable? Right here, there are 3 of them. So there are 3 favorable outcomes. And how many total outcomes are there? Possible outcomes. Well, I have 2 possible sides in the first nickel, and the second 2 nickels also have 2 sides. So 2 times 2 times 2 gives me 8. So the probability is going to be 3/8, or 37.5%.